Hi, everybody. I'm Chris Preimesberger, editor of eWEEK.com. Thank you for joining us today for this latest segment of eWEEK eSpeaks. It's a series of informal conversations with IT thought leaders from every corner of the business and every corner of the world. Our interviewee today is Noemi Greyzdorf, and Noemi is the Vice President of Marketing at a company called Vcinity, and Vcinity leaves out the first I, so it's this VC, etc. Anyway, Noemi, welcome.
Thank you. Nice to be here, Chris.
Yeah, I remember, I think we communicated probably a few times in the past when you were at IDC as one of the storage analysts, and when I was I was the storage writer at eWEEK for quite a while, and I remember you always being very responsive and offering very good insight into everything. So I expect that today.
Oh, it's a high bar too. Very high bar.
So Noemi, tell me a little bit about your background and then about Vcinity and what it does.
Sure. So I've been in the storage industry for 20 plus years, holding various roles. And as you mentioned, spent some time as an analyst at IDC covering storage, both file-based storage as well as storage and virtualized infrastructures. That of course led me to more around cloud adoption and deploying applications and data in the cloud. Most recently, I worked with a couple of different startups, Atavium, then spent some time at Quantum, and have recently joined Vcinity. So Vcinity was originally founded to develop some chip technology by the federal government. But as the technology has evolved, the intellectual property is really in the software. And what it enables users to do is actually deploy compute resources, so deploy the application wherever they need to, and then be able to process data in place. In other words, you no longer have to move data to the compute or move the compute to the data. You can deploy them in or run them wherever they are, and you can process it in place. And so that's what Vcinity did. That's really the key. I mean, there's obviously all sorts of IP and magic that goes into it, but the end result is that we really eliminate that time lag due to the need to move large sets of data and store them all over the place.
Yeah, magic indeed. Bringing the computing processes and production power to a data store that is not anywhere near where it is, and get the job done and get it done efficiently. Can you just give me kind of a high level of how that works? I mean, you won't give away any secret sauce or anything, but if you could tell me how that works, that would be fabulous.
Sure. So the gist of it is we took RDMA, which is really a low latency protocol deployed within the data centers, and we said, okay, what would it take for us to leverage this protocol across the WAN? So we have 32 patents and more pending, and all of our patents are really to take RDMA and to be able to move data or to give access to data over the WAN. So this is not over TCP, this is a peer-to-peer connection. So you have to have our software running on both sides. But generally, if you deploy it, then you can reach in and get the performance of a LAN over the WAN. Now we're not eliminating latency, so I just want to make that very, very clear that this is not magic or some kind of a network wormhole that you can just jump through and skip to the other side. You will experience the initial latency. So whether it's 100 milliseconds or 500 milliseconds, you will experience it, but you will experience it only on the initial byte of data. And then after that, you will experience the LAN connection, and though it was a LAN connection.
Okay, all right. So that clarifies it a little bit more for me. What kinds of What kinds of customers use this, or is this particular software really good for? I can imagine really, really large workloads that are hard to transport, or that are maybe regulated and you don't want to transport. Is that kind of a fair statement?
Oh, absolutely. So there's a number of different areas, and really it's a parallel play, right? So it's not as specific to a vertical. It's really fairly general. So it addresses the edge compute challenge. So we have data created at the edge. We have, whether it's IoT devices or telemetry, or even if you're in a movie, you're creating a movie, or you're recording, producing something, and you're at an far off place. Whether it is you're doing oil and gas or energy exploration in the middle of the ocean, or something to that extent, you have a high latency connection. And instead of waiting to move the data, whether it's shipping drives, arrays, or trying to move it over the available bandwidth, you're going to have a lag in terms of how long it's going to take you. So what we're enabling you to do is to connect to that data where it is being created and start manipulating it, processing it. Think of like smart cities, when you have, for example, video surveillance data that is being collected and you want to correlate it across multiple instances throughout a city or throughout a geography to get a better picture of what's going on. So maybe you would log in, or you would connect to the data, you would process it, and you would get the analytics back. And it could be the analytics are running across multiple sites or in an individual site, right? So you're really gating your insights and your action items and much faster, because moving data over a long haul WAN can take hours if it's not a lot of data and the latency is not too high, to days. And in some cases, if you're trying to move, tens or hundreds of terabytes, for example, into the cloud for some, for Snowflake or for some other kind of AI workload, you're going to actually ship an array. So they're going to ship you an array, you're going to download your data, and then you're going to ship it there. They're going to upload it. So it's going to take a significant amount of time. Plus, every time you move or create copies of data, it exposes you to security risks, right? Somebody, doesn't follow the settings, or the firewall has a hole in it, and all of a sudden you become much more liable for anything that can happen to the data. So in any of those instances, so whether it's a movie production, whether it's security, physical security, it can be one of the other big use cases for folks who want to adopt the compute in the cloud, sort of be the elastic compute resource and take advantage of it. But in order to do that, you have to move the data, right? And to your point, maybe the data cannot be moved because there's some regulatory rule that says you can't, or there's a security concern, or there's a cost associated with it, or there's a timing issue. What we enable you to do to actually deploy those compute in the cloud and then mount the repository of data wherever it is and process it in place.
Wow, what a solution. I mean, for so many use cases, like you just mentioned. In fact, you beat me to it. I was going to ask you for some use cases, and you read my mind, and you touched on a few that we can all picture, filming a movie at a long distance, that kind of thing, or, a whole string of, oil and gas discovery sites that are bringing data in all over. But that's great, and this really solves so many problems for those kind of use cases, no question about it. So what trends are you seeing here now? How long has the company been in business doing this?
So Vcinity was formed in 2018, and it sort of acquired / merged with Bay Microsystems. So the IP has been in the field and has been sort of battle tested, no pun intended, because it was or has been deployed in federal government for a number of 10+ years. the Vicinity as a company was formed in 2018 to really bring this technology to more of a commercial market, to commercialize it more, to to create that connected enterprise, because that's really what it does. It creates a connected enterprise.
Yeah. What was the government, just real briefly, what was the government using it for? I mean, you were putting it into chips, right? So it was in physical form.
So originally, and today, the software still runs on a FPGA, for example, to accelerate it, because it needs some more oomph. Federal government has predominantly used it for long haul communications and being able to do exactly what I've described, provide insights and analytics in real time, so that they can provide the kind of security and operations management that is required. Beyond that, I don't think I have a security clearance to say much more.
Okay, fair enough. I understand. I get it. Well, Naomi, we just have a minute or so left here, so thank you so much for joining us today. And this is just a really, really interesting technology. And with the edge, the whole concept of the edge exploding like it is now, it seems like, this technology is got an unending list of use cases that it could be utilized for. And can you give me an example of maybe one or two of maybe a smaller company or a mid-sized company use case? If it's not an oil and gas explorer or a movie maker, what other kinds of ways can this be used?
Sure. So think of, for example, we are working with a customer right now who is, so first of all, it can take advantage of things like 5G networking, so it can really enable the adoption of that technology. But we're working with a customer right now, and they have a lot of data. They have like petabytes of data, and they want to take advantage of Snowflake. And so traditionally what they would do is they would actually, they would have to load up the data on the disk array, ship it, and then they would import it and do all this stuff. So right now we're working with them on enabling them to connect to the repository that they have and not have to move the data at all. Or we can enable them to move the data much, much faster.
That makes a lot of sense. The idea of shipping an entire array to a far off location and plugging it in, turning it on, making sure it all works. That's the way it used to be done. And I remember in the old days, Sun Microsystems, for example, had that shipping crate or shipping box, portable data center, 40 feet long by 8 feet. This big shipping thing. And they would load that with data center equipment and then ship the whole thing somewhere. I remember that. I don't know how well that all worked, but it was something they were doing for a long time. They weren't the only ones doing it either. A couple of other companies doing that too. But now it's all in the web and it's all virtualized everywhere. It's amazing. So.
Well, if you have 100 terabytes and you need to move it, that's still probably the fastest or most efficient way to move that data, other than maybe than using tape technology, because trying to move 100 terabytes over, even if you have a really good 10 gig connection, if your latencies are, WAN latencies, then you're looking at a long, long haul there.
Long time, for sure. All right. Well, Noemi Greyzdorf from Vcinity, thank you very much for joining us today on eSpeaks.
Thanks, Chris. It's nice to speak to you again.
Yeah, this has been fun. Enjoyed it. And for everybody following along to the end here, thank you very much and have a great rest of your eWEEK. Thanks for joining us on eWEEK eSpeaks. Go to eWEEK.com to hear more conversations with IT thought leaders.